There's a rule in nature that most living things quietly follow. You are born, you grow, something tries to eat you. Most of the time, that something succeeds. You become food, and the system continues. The whole enterprise of life on Earth runs on this agreement, the eaten and the eater, locked in a balance that took hundreds of millions of years to negotiate. Most animals follow the rules. The cane toad did not get the memo. In the span of less than a century, a single deliberate human decision released an animal onto a continent it had never set foot on, and that animal has been systematically dismantling the ecosystem ever since. It has poisoned crocodiles. It has driven lizards toward extinction. It has evolved, in real time, in front of researchers who still can't quite believe what they're watching. It cannot be reasoned with. It cannot be easily contained. It eats almost anything, and it was our idea. To understand what the cane toad is now, you have to understand what it was supposed to be. It's the 1930s. Australia's sugarcane industry is in crisis. The culprit is the larvae of the cane beetle, a grub that eats the roots of sugarcane plants from underground, killing the crop before it ever has a chance to grow. Chemical solutions had been tried. They hadn't worked, so someone suggested something different: biological control. The concept isn't inherently crazy. If you introduce the natural predator of a pest into the pest's environment, the predator eats the pest, the population drops, balance is restored. It sounds elegant. It has even worked before, in isolated cases. Australian officials had heard about a promising case in Hawaii. A particular toad had apparently been useful in controlling a similar beetle on Hawaiian sugarcane plantations. The toad in question was Rhinella marina, the cane toad, large, voracious, and allegedly very good at eating beetles. So in 1935, Australian officials made their decision. They commissioned a rigorous study to carefully evaluate the environmental impact of introducing a non-native predator to the Australian continent, a landmass biologically isolated for millions of years, home to ecosystems found nowhere else on Earth, filled with animals that had evolved in complete separation from the rest of the world's fauna. They did not do that. What they actually did was transport 101 cane toads from Hawaii to Queensland and release them into the wild. No controlled trials, no peer-reviewed risk assessment, no pilot program. They just let them go. Before we get to the catastrophe, it's worth taking a moment to understand just how strange this animal is on its own terms. The cane toad is not subtle. It is large. The biggest ever recorded, measured nearly 40 centimeters, roughly the length of a standard school ruler, and weighed almost 3 kilograms. That is not a toad. That is a small, lumpy, extremely confident brick with legs. It is ugly in a way that feels almost deliberate, like nature was trying to make a point. Dry, warty skin, flat, expressionless eyes, a permanent face somewhere between mild contempt and deep confusion. If evolution is supposed to produce finely adapted, elegant creatures, the cane toad suggests evolution was having an off day and didn't particularly care. It will eat almost anything it can fit in its mouth. Insects, small reptiles, small rodents, birds, dog food if you leave the bowl outside, household garbage, other frogs. The cane toad's approach to nutrition is less apex predator and more, everything is food if you're not too picky. There is something almost admirable about this level of commitment. Almost. But here is the detail that makes everything else worse. The cane toad is poisonous, profoundly, almost theatrically poisonous. On each shoulder, adult cane toads carry a pair of large parotoid glands. When the toad is threatened, these glands secrete a thick, milky white substance packed with toxins, the most dangerous of which are called cardiac glycosides. When an animal bites a cane toad, as any sensible predator might naturally attempt, that venom enters the mouth almost immediately. What follows is not pleasant. The cardiac glycosides interfere with the ion channels in heart muscle cells. Sodium floods in. Potassium builds up between the cells. The electrical signals that regulate the heartbeat go haywire. The heart begins to beat erratically, then uncontrollably. Breathing becomes labored. Convulsions follow. In many animals, death arrives within minutes. This is not a mild deterrent. This is a weapon. And in the cane toad's native range across South and Central America, it works as a weapon, Because the local predators have had millions of years to learn, through evolution, to avoid it. The broad-snouted caiman, for instance, has developed specific biological mechanisms to neutralize the toxin's effects, a hard-won genetic adaptation, built over deep time. Australian animals have had none of that time. They had never encountered a cane toad before 1935. They had no evolutionary reason to fear a squat, slow-moving, vaguely ridiculous-looking toad sitting on the ground. And so they tried to eat it. And so they died. Let's return to those 101 toads. By 1940, 5 years after the initial release, there were an estimated 1,000 cane toads in Queensland. By the 1960s, tens of thousands. By the 1980s, millions. Today, Australia is home to somewhere between 200 and 300 million cane toads. Let that number settle. The continent that received 101 toads now holds, conservatively, 200 million of them. To understand how this is even biologically possible, you have to understand how cane toads reproduce. A single female can lay up to 40,000 eggs in a single clutch, not per year, per event. She deposits them in long, gelatinous strings along the edges of ponds, puddles, irrigation channels, drainage ditches, any still fresh water she can find. She can do this multiple times a year. In the natural world, an animal that produces this many offspring does so because most of them are expected to die. The arithmetic only works if the mortality is brutal. A sea turtle lays 100 eggs because statistically, maybe 2 will reach adulthood. The overwhelming numbers compensate for the overwhelming losses. But in Australia, there are no effective predators of cane toad eggs, tadpoles, or juveniles. The eggs are toxic. Fish and turtles that attempt to eat them often die. The tadpoles are toxic. The juveniles are toxic. At every single stage of development, the cane toad is already armed, so the eggs hatch. The tadpoles develop into juveniles. The juveniles emerge onto land, and nearly all of them survive. The pond goes dark with tadpoles. Not dark in a poetic sense, literally dark. The water turns black with the density of them, edge to edge, shore to shore. You are not looking at a healthy ecosystem. You are looking at an occupation. Here is a partial list of Australian species pushed into serious decline, or toward extinction, as a direct result of the cane toad: the Australian monitor lizard, the northern blue-tongued lizard, the Australian water dragon, the king brown snake, the common death adder, the northern quoll. These are not obscure animals at the edges of the ecosystem. These are predators and keystone species whose presence structures the food web around them. When they decline, other populations spiral in ways that can take decades to fully trace. The absence of a single predator creates vacuums that ripple outward through the entire system. The freshwater crocodile has been hit particularly hard. A 2008 study monitored a population at the mouth of the Victoria River across 3 years, following the westward advance of cane toads into their territory. In those 3 years, 77% of the population died. The deaths tracked the toad invasion with almost perfect correspondence. As the front line of toads moved west, the crocodile deaths followed immediately behind it. Freshwater crocodiles are not fragile animals. They are ancient, armored, apex predators. They have survived every mass extinction this planet has produced over 200 million years. The cane toad killed 77% of one population in 3 years. Let that sit. Here is where the story stops being a disaster narrative and becomes something considerably stranger. In the 1940s and 1950s, cane toads spread across Queensland at roughly 10 kilometers per year. Already alarming, already faster than any effective response could manage. Today, the western front of the cane toad invasion is moving at 50 kilometers per year, 5 times faster, and still accelerating. Researchers initially wondered if the toads were somehow catching rides on vehicles, hitchhiking their way across the continent rather than walking it. To test this, they fitted individual toads with tiny radio transmitters and tracked their nightly movements. The toads were not hitchhiking. Individual toads were covering up to 1.8 kilometers in a single night. This is, for context, faster than any other frog or toad species ever studied. Not marginally faster, dramatically faster. The cane toad had quietly become the most mobile amphibian in the scientific record. But why? What had changed between 1940 and now? The answer is evolution, and the speed of it is what has genuinely unsettled researchers. Scientists compared preserved museum specimens of cane toads from the 1940s to modern toads caught at the current invasion front. The difference was unambiguous. Over roughly 60 years, a blink in evolutionary time, the legs of Australian cane toads had grown by more than 25%. Longer legs, longer stride, more ground covered each night, more territory reached before competitors arrive. And crucially, the toads at the very front of the invasion have the longest legs of all. Behind them, in territory already saturated with toads, legs are shorter, because at the frontier there is almost no competition, no overcrowding, abundant food and space. The toads that arrive first thrive. The toads that arrive first happen to be the ones with the longest legs. Their offspring inherit those legs. The front moves faster, the legs grow longer. This is natural selection playing out in decades rather than millennia. A process biologists once assumed required vast geological time is being documented in a single human lifetime, on a continent that had no say in the experiment. We released 101 toads. In less than a century, those toads evolved into a faster, more efficient version of themselves, specifically shaped by the conditions of invasion. The machine we set in motion has been quietly upgrading itself the entire time. The situation is not without hope. Nature, it turns out, is obstinate. Some Australian animals are adapting, not enough to reverse the damage, not fast enough to save every affected population, but adapting nonetheless, and doing so in ways that nobody predicted. In certain black snake populations that absorbed heavy casualties from cane toads, researchers have observed a measurable shift over successive generations. Snakes with smaller mouths are surviving at higher rates. The reason is straightforward but almost poetic in its simplicity. A smaller mouth physically cannot fit an adult cane toad. The snakes that anatomically cannot eat the toad do not die from eating the toad. Their genes persist. Over generations, the average mouth size in those populations is shrinking. Evolution in reverse. A predator adapting not to better hunt its prey, but to avoid it entirely. And then there are the Australian water rats. These animals have done something that deserves its own documentary. Faced with an abundant, heavily toxic, essentially uneatable food source, certain water rat populations have figured out a technique. They flip the toad onto its back, pin it, and then, with a precision that researchers have genuinely described as surgical, carve directly into the chest cavity to extract the heart, liver, and edible muscle tissue, carefully working around the poison glands in the shoulders. They taught themselves open chest surgery on a poisonous toad, not through millions of years of genetic adaptation, through learned behavior, observation, trial, error, refinement, passed between individuals across generations. A rat worked out how to safely disassemble a chemical weapon for lunch. Australia, as always, produces remarkable wildlife. If the story ended there, invasive species causing chaos, native species slowly adapting, it would be a fairly standard ecological tragedy, grim but comprehensible. But the cane toad cannot do anything normally. The toads have become so numerous, so thoroughly dominant in parts of their range, that they have effectively exhausted their external competition. No meaningful predator, nothing to regulate the population, nothing keeping the numbers in check, except themselves. Cannibalism has evolved in cane toad populations, not as an occasional desperate act in lean times, as a structured, systematic, apparently adaptive behavior. Adult toads eat smaller toads. More significantly, the tadpoles eat each other, and the efficiency of it is genuinely startling. Researchers found that a small group of more developed tadpoles could consume 99% of the freshly hatched eggs from a single clutch. 99%. A species that lays 40,000 eggs per clutch has evolved, under pressure from its own density, a mechanism by which nearly all of those eggs are consumed by the previous wave of its own young. Scientists had observed cannibalism evolving in animal populations before, but never at this pace, never with this degree of systematic efficiency, and never in a population whose explosive growth had itself created the conditions that made cannibalism the most adaptive available strategy. The cane toad, in the complete absence of external predation, essentially invented its own predator, and that predator is itself. Australians understandably want the cane toads gone. The options currently available range from inadequate to deeply undignified. Community culling groups organize toad-busting events. Volunteers with torches and buckets fanning out at night to collect toads by hand. Golf clubs have been used. Air rifles. People have driven over them with cars, deliberately, and apparently without hesitation or remorse. The official government guidelines, and this is a sentence that genuinely exists in formal documentation, recommend placing captured toads in a sealed bag in a domestic freezer until death occurs. The most successful invasive species in Australian history is to be neutralized using an appliance most people own. Individual removal does not work. It cannot work. With 200 million toads across a continent, culling individuals is the ecological equivalent of bailing out the ocean with a teaspoon. You feel productive. The numbers do not change. This is why researchers have begun looking at solutions that operate at the scale of the actual problem. The most ambitious and most debated is a genetic approach called a W-shredder gene drive. Here is how it works. Cane toads use a sex determination system called ZW. Males carry 2 Z chromosomes. Females carry 1 Z and 1 W. It is the egg, not the sperm, that determines the sex of the offspring. A W-bearing egg produces a female. A Z-bearing egg produces a male. A W-shredder is a modification placed on the Z chromosome. When a toad carrying this edit reproduces, the modification causes all W-bearing eggs to fail. Only Z-bearing eggs remain viable. Fertilize those with a Z-carrying sperm, and every offspring is ZZ, male. Release enough W-shredder males into a wild population, and the modification spreads through the breeding pool. The proportion of females begins to fall. Fewer females means fewer viable clutches. Fewer clutches means the population begins to contract. Given sufficient time and sufficient carriers, the population collapses. In theory, the objections are real and deserve to be taken seriously. We have been down the road of unintended consequences before. 1935, 101 toads, no environmental study. A gene drive, once released, is not easily recalled. If it behaves unexpectedly, if it spreads beyond the target population, if it interacts with other species in unforeseen ways, the consequences may be difficult to contain and harder to reverse. But the other side of that argument is this. The cane toads are already there. The damage is already happening. Native species are already declining. The crocodiles are already dying. The front line is already 50 kilometers further west than it was last year. The luxury of clean hands, of declining to intervene because intervention carries risk, is a luxury the Australian ecosystem cannot currently afford. We introduced this problem. The obligation to resolve it came with that decision, whether we wanted it or not. The only remaining question is whether we approach that obligation with the rigor and caution the original decision so conspicuously lacked. 101 toads. That is where it started. A number small enough to transport in a single truck. A decision made without a single environmental study, by people who were certain they understood the system they were intervening in. Today, somewhere between 200 and 300 million toads move across Australia. They are faster than their grandparents were. Their legs are longer. Their tadpoles are cannibalizing each other with a precision that still surprises researchers. The front line moves 50 kilometers further west every year, and the toads driving it are better adapted to invasion than the generation before them. And we are now developing genetic engineering tools to try to engineer our way out of a problem we engineered ourselves into. There is something almost instructive in the scale of the absurdity. The cane toad is ugly, unkillable, and entirely our fault. It has turned one of the most isolated and biologically extraordinary ecosystems on Earth into a live case study in what happens when human certainty meets biological complexity and loses. The deep irony is that through all of it, the cane toad itself is thriving. It is not struggling, it is not threatened. It is fat and unhurried and chemically armored, and present in every corner of its adopted continent, doing exactly what it has always done: eating, reproducing, moving forward. It never asked to be here. It was placed here, by us, with no preparation and no plan, and it simply got on with the business of being alive. And somewhere in Queensland tonight, a toad the size of a small shoe is sitting under a porch light, waiting for insects, entirely unaware that it is the subject of a continental ecological crisis, government task forces, genetic engineering proposals, and countless hours of desperate human hand-wringing. It looks profoundly unbothered. Honestly, respect. If this video taught you something genuinely new, subscribe. There are stories on this channel that will make the cane toad look completely normal by comparison. Drop a comment with the fact that hit hardest. I read every single one. See you in the next one.